Okay, greetings everyone. Welcome into my channel. I am Professor L, and this is a math tutoring session for anyone who needs help with their math. Up to a certain extent, I'll probably have to cut it off about trig and then maybe calc 1 or 2. Um, at the highest level of math that I've taught and instructed is trigonometry and but I have taken all the way through advanced calculus in college. That was a long time ago. So, yeah, just a recap. So, I've been doing this for about a month, and it's just really about me trying to do something with the math. I love math, and I love studying it. And I majored in mathematics in college. Um, and that was a pretty big undertaking. But I was successful, and I did complete my bachelor's in mathematics. And just part of this project is me wanting to share the math. Um, so I prefer easier topics at first because it's been so long since I've really thought about a lot of these topics that it's almost like I'm learning them again. But I really appreciate this opportunity, and I am willing to help if it's just pre-algebra, or maybe it's earlier than that, the basics, the essentials, whatever it is, simple math. I prefer the trigonometry because that's my jam. But again, this isn't about only me. I am using this platform as an opportunity for me to grow and personally develop. Um, and it's something that I've not ever been really good at, presenting, especially with the camera. I'm very informal, and so I realized that a grow opportunity for me is to get a lot better at communicating through this type of medium. Anyway, so I'm going to go ahead and get right into it. I just wanted to remind everyone that who I am and what I'm doing. So if you happen to see my videos or catch a video, it's not like a clean, neat, tidy, put together presentation. It's just me informally hanging out on a board doing math, and maybe possibly helping someone out there to clear up a quick question, or if they want to take a deeper dive and actually see something written and worked out on my board, I'm happy to do that as well. And it's just me doing it from 6 p.m. to 7 p.m., and that is Central Time. So, all right, I'm going to go ahead and get into it. What I did was I picked another polynomial. It's a cubic function. It's a third degree polynomial. And I wanted to go ahead and start by, I do make a lot of mistakes, and I realize at first I'm probably going to make more than I will. And I'm hoping that I'll get to the point where I'm not making so many arithmetic errors. But if I don't call myself out, then I might not be so quick to fix the problem. But I did notice a mistake here because 3/8 is positive, and that would have put me over here. And it's so frustrating because I have no way of fixing it. It's on camera, and it's like I look like I can't even add and subtract right. But really, most mistakes, even at the higher level math, were all due to you know minor arithmetic errors. So that's what they even say in calculus and higher differential equations and all of that. After calculus, even most of the mistakes happen with the adding, subtracting, multiplying, and dividing. Unfortunately, you're dealing with all these crazy formulas and theorems, and this is really where most mistakes are made. But I did re-add this. I had this right. This was correct. But then when I put in the calculator, it doesn't equal 203. I think it was 193. So 125 minus 200 is negative 75. And then 20 plus 48 is positive, let's see, that would be positive 68. And that's over 8. So 75 from 68, 75, so let's see, 65, 70, that's 7. So it's negative 7/8. So when we are over here at 3, we're not at negative 3/8, we're at almost, and it looks like this function dips down just a little bit more, because negative 7/8 is almost negative 1. It's out here. So I just wanted to correct my mistake, and I apologize for anyone who was watching and caught that. And the goal here is not for me to look pretty and perfect. The goal is for me to remain effective and develop skill. So again, it's going to happen, and it is brutal and tragic when it does, but like Bob Ross says, he says we don't make mistakes, we just have happy accidents. So I have to just go with that one. All right, so we've got negative 7/8, and that was that was in between 2 and 3 here. So if we put a value in here and say it was 2.5 or something, then it would be negative 7/8. And we should probably go ahead and stay consistent with our fractions. So that would be 5. 2.5 is 5 halves. 5 halves. And then we would have negative 7/8 there. All right, but I've picked an entire new function, and we're going to give this another go. And this will just be anyway, this will be me just practicing and trying to work on my board. There's some pop-up that appeared on my computer, and I don't want to mess up my stream if I click on something, but it's like accept or uninstall, so I don't know what to do. I just try to ignore it and pretend it's not there. I won't be able to see half of my board, but maybe it won't matter. Let's just go with it. All right, so I'm going to leave that title up because we are still graphing a cubic function and we're analyzing it. And so it's fine. We'll just go ahead and leave it up. So the function that I picked out, f of x, and it was 2x cubed minus 3x and it's minus 10. And what I did was I cheated a little bit because I wanted to find a function that let's see. I wanted to pick a function that I knew would have a clean 0. That would make it it's just a little bit better to see, especially when you're practicing. And the title of this live stream, even though it is math help, so I prefer to help. I did title it using calculus to analyze. And to be honest, you can use this calculus, this method, to find the vertex of your parabolas as well. So I showed two ways already to find the vertex of a parabola, which is very significant. You can also use derivatives to find that local minimum and maximum. It's the first and second derivative. And so in a nutshell, what a derivative is it's a function that is derived from another function using a general rule. And so there are different rules of finding derivatives. There's a complicated definition for what the reason why a derivative works, and it goes into like limits, and so they wait and reserve derivatives for calculus, and the reason why they do that is just because of the complication definition. But essentially, what a derivative is just like what the word sounds like. It is a function that is derived from an original function, just using general rules. And one of the first rules that you learn after you learn the formal definition of a limit, the limit definition of finding a derivative, after you find that, they always put you through that first, which is a long, brutal undertaking. But then you learn the power rule. And the power rule, essentially, that's the one I'm going to be using the most here. So what we're doing is we're going to use the power rule and find the first derivative of this function. And use, well, we're going to find the values that we had found yesterday, because those are the real values on the graph that we need. But we're also going to find the maximum and minimum values using the derivative. And so one of the many, many applications of the derivative is finding these critical points and values on the graph so that you can sketch a graph without the use of technology. Okay. And after you get really good at and well practiced and more familiar with using the derivatives to analyze the graph, then we might be able to look at some polynomials that don't have clean intersections. But for now, I want to try to find them that factor into clean values. So this one, in my search today to try to find a polynomial that was clean, I found that x equals 2 is a 0. So just to start out, we're going to go ahead and factor this polynomial before we take the derivative of it. And if we want to find the factor associated with the 0 x equals 2, we're going to reverse solve this equation for 0. Now, when you do that by just subtracting 2 from both sides, and you get x minus 2 equals 0. And when you have your factor equal to 0, or you have your 0 set equal to 0 like this, then you've found your factor. And the reason why I wanted this factor was that I could use long division of polynomials to divide. So what I'm doing is I'm taking x minus 2 and I'm going to divide it into 2x cubed, and then I'm going to have a placeholder, so we'll say plus 0x squared minus 3x minus 10. The method only works if you put a placeholder, and it has to be in descending order. So it's very specific to the method. And if you don't put that 0 in there as a placeholder, it won't work. All right, so per the method, eventually we'll get into synthetic division, and I'll start doing synthetic division. It's just that I haven't really introduced synthetic division, and we need to get good at dividing the polynomial and familiar with that before we get we understand the synthetic. It does make it a lot easier though once you learn the synthetic. All right, so we're taking 2x cubed and we're dividing it by x. And so maybe I'll just do it off over here. So we'll say 2x cubed divided by x. And this is going to be 2x squared. And then per the method, we're going to take 2x squared and we're going to multiply it by the divisor. So it'll be x minus 2. And so we've got 2x squared. We're going to put that 2x squared here. And then we're going to do this multiplication. 2x squared times x is 2x cubed. And 2x squared minus 2 is negative 4x squared. And that's going to be the polynomial that we're going to put here. So we're going to subtract it. Subtracting 2x cubed minus 4x squared. And remember, when you subtract, you're carrying this division or the subtraction, you're distributing across both terms. So that becomes a positive. And then 2x cubed minus 2x cubed is 0. And then you have 0 plus 4x squared is 4x squared. And then you're going to bring that term down, negative 3x. And then you're going to repeat the division algorithm. So you have 4x squared divided by x. Okay. And 4x squared divided by x is 4x. And then I'm going to take that 4x, I'm going to multiply it by the divisor, x minus 2. And that's 4x squared. 4x times negative 2 is negative 8x. So I'm going to put that here, 4x squared minus 8x, use parentheses because I'm subtracting. And I'm going to remember to put my linear term here. And it's a positive, so it's going to be plus 4x. And you're just keeping track of your placeholders. So you're putting your square term above your square and your linear term above your linear value. And we're going to go ahead and perform this subtraction. This becomes negative. This one will become positive when you do that distribution. And then we're going to go ahead. So 4x squared minus 4x is 0. And then positive 8x and minus 3x is 5x. And then we're going to go ahead and bring down our negative 10. And we're going to have to perform that algorithm one more time. And we should get a 0 because there shouldn't be a remainder. If you have a 0 for your function, it's telling you that at that value, when you evaluate your function at the value, the 0, you're going to get 0. So if you have a clean value, when you plug in, you do this at the long division, you're not going to have a remainder left over because it's a clean division. But the reason why I'm doing the division is not to get the 0, the reason why I'm performing this division is so that I get this polynomial that's left over so that I can find the other factors and I can completely break this polynomial up into its prime factorization, just like you would any number. You're splitting it up into its factors. I hope that makes sense. All right, so anyway, 5x minus 10 is going to get divided. So 5x is going to get divided by x. So 5x divided by x equals 5. And we're going to take that 5 and we're going to multiply it by our divisor, x minus 2. And so we have 5 times x is 5x. And 5 times the negative 2 is negative 10. And so we have 5. That's our number here. It's positive. So we'll go ahead and say plus 5x. And then we're going to put it here, 5x minus 10. And then remember to subtract. And if you can remember to subtract and change the sign of your other term, and you don't probably need the parentheses, but I like to keep track of the parentheses. It helps me remember, especially if I'm tired or I get in a hurry. So we've got 5x minus 5x is 0, and plus 10 minus 10 is 0. So we've effectively found the polynomial. That's a check in place if you don't have a remainder. And we have this resulting polynomial. So we're going to try to see if we can get this one to factor, and I think it might factor. We'll try. I really feel like I want to try to factor it now, especially since yesterday I upset myself. I didn't see the factors readily because when your leading coefficient's not 1, it's not the easiest thing, but it's doable. So, yeah, we'll just try to see what happens. All right. So, we've got this thing going on. We've got x minus 2 times 2x squared plus 4x plus 5. And quadratic equations, when you're trying to find these zeros, yes, you're looking for specific values when you're crossing the y-axis, but there are so many actual real applications to quadratics, and one of my favorites is projectile motion. But anytime you need to minimize or maximize values, you're going to use the quadratic, and it's very, very useful. It has a lot of applications in physics. So we might have to get back into some of the word problems for that because we could get into the projectile motion, and I'm not a physics expert, but I did enjoy working on some of those, the diagrams. All right, so we have to figure out the other two factors, and it's a little bit easier to figure out a second degree polynomial because we have so many options. We could do the quadratic formula. We can complete the square, or if it factors, we can try to factor it. So I'm first going to try to factor it. And let's see. 2x squared plus 4x plus 5. And what we're doing when we're factoring is we're looking for two numbers, okay? And number here and number here. And when you multiply the numbers, you get 5. And when you add the numbers together, you get 4. But it throws a monkey wrench when you have an x here, or another number besides 1. So we're going to multiply 2 times one of these values, and then we're going to add and somehow get 4. So let's see, if it was 5 and 1, that's the only two numbers. We would have to put 5 here because we wouldn't want. Let me see, let's just try it. So it's going to be, nope, that's going to give us 7. So let's see if we can put the 5 here. And see if we can get it. So 2 times 5 plus 1. All right, so I don't see the factors again. So we're going to go ahead and do I use the quadratic formula, or do I go ahead and try the completing the square method? That is totally, oh, that's a toughie. Here, let me just think about it for a second. I haven't shown completing the square method yet. We could go ahead and get into it, but let's see if I can get it real quick. So we'll have y equals, let's see, I'll just go ahead and try to put it up here. So we have y equals this polynomial, 2x squared plus 4x. My ruler fell. How does this happen? I'm sure that was really loud. Okay, plus 5. And so what you have to do for completing the square method is you have to get this number right here. You've got to get it to be the coefficient, your leading coefficient has to be 1. So I think you have to do this. So that's 1/2 y equals x squared plus 2x plus 5/2. And all right, so now that we have this one, we can kind of do it. So what we're doing is 1/2 y equals, oh my goodness. So we're just going to use the quadratic formula. I apologize about that, but this is so much faster, and I'm not trying to show completing the square. I'm trying to show how to analyze the graph using derivatives. So we'll go ahead and do it here. So we have y equals 2x squared plus 4x plus 5. And so A equals 2, B equals 4, and C is equal to 5. So I'll have to finish over there, but we'll get it started here. You have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so we ran out of room, so we'll finish it up here. X equals negative 4 plus or minus the square root of 4 squared 16, and then 4 times 2 times 5. That's going to give me a negative discriminant. Oh no, this is not real roots. This is not. Okay, we'll just go with it. 4 times 2 is 8 times 5 is 40 minus 40. Maybe I should have done a little bit better job of picking one, because we'll have to talk about I, the imaginary unit. So -4 plus or minus the square root of 16 minus 40. Ooh. Unless I made a mistake, that's -24. All right, I'm gonna have to plug this in my calculator and check it. So we've got -4 plus or minus square root of -1 times, let's see, that's 6 times 4 over 4. So I'm getting -4 plus or minus, that's going to be 2 radical 6i over 4. That is ugly. But there is a way to deal with this. So -4 plus 2 radical 6i over 4 and -4 minus 2 radical 6i over 4. And see if that isn't even true. All right, let's see. Two x cubed minus 3x minus 10. Okay, it's got to be right. So basically, this is 2x. I'm going to have to find another polynomial because I'm not trying to graph these. So it's saying that these zeros are over here in the complex plane. So what is that? All right. Let me see if I have a list real quick. Well, there's this one, but can I still take the derivative of it? All right, so this is not something that I am prepared to even talk about. The imaginary unit. It's like there's a complex plane, and for graphing that value, I'm gonna erase all this. I'm going to keep this, and I'm going to keep my other 0, x minus, so that was x minus 2. And this is so good for me because it's making me remember all of this math. Today was the first day that I actually thought about, oh yeah, I can use calculus. So let's just talk about the derivative and use the derivative to analyze this function, even though I have the zeros and they're not pretty ones. Because we have x equals 2. These are all of the zeros for this function. And all this is saying is it's only touching the x-axis one time. And there's these other values that are existing. Well, I can still use the power rule to evaluate f prime of x. And what you're doing for the power rule is you're bringing the exponent down and multiplying. So it's 2 times 3 the x, and then you're subtracting 1 from the exponent. So it's going to be 3 minus 1. And so you're going to do the same thing, x to the first. So it's minus 3 times 1 to the x to the first power minus 1. And then the same thing where that constant term will just drop off. So it'll be basically you have x, this is your x to the 0 term. So when you try to apply the power rule, you get negative 10 times 0, x to the 0 minus 1. And so when you multiply anything by 0, you just get 0. So that's kind of redundant. But 2 times 3 is 6. X to the 3 minus 1 will be squared. And then this is going to be 3. And the x to the 1 minus 1 is just x to the 0, and then that's minus 0. So the first derivative of this function is going to be 6x squared minus 3. And then what it's saying is, so this is f prime of x, f prime of x is by setting the first derivative equal to 0 and solving this equation for x is telling you critical values in the graph. So I'm going to go ahead and erase all of this and keep the zeros here. So what it's telling you is that it's only got one clean crossing the x-axis. Let's see if I can go ahead and sketch the graph of this function, even though we have this ugly thing going on. So you set, back to this, you set this equal to 0, and then you figure out what x is equal to. And since it's squared, you could have a potential of 2x values. So you go to try to factor it, and I can pull a 3 out. So if I pull a 3 out of both of those numbers, I'm going to get 2x squared minus 1 equals 0. So I'm looking at now 3 equals 0, which it doesn't. And so 2x squared minus 1 equals 0. And so then you add 1 to both sides. And I'm going to switch this around, say 2x squared minus 1 equals 0. And so I'll solve this for x, and I'm going to get 2x squared. So if you add 1 to both sides, it's going to be equal to 1. Divide by 2. This is going to be x squared equals 1/2. And then to solve for x, you just take the square root of both sides. And it's going to lead to 2 values. And when you take the square root, you have a plus and a minus. So you're going to end up with x equals plus or minus the square root of 1 over the square root of 2. And then you have to rationalize that. You rationalize the denominator. Square root of 1 is 1. And then remember how to rationalize the denominators. You're just multiplying it by the quantity 1 to make it pretty. So you're going to have looks like radical 2 over 2 plus or minus. So that these values right here is saying that there's critical points in the graph. So let's see if we can locate them on the graph. And it's just been a long time for me. So hopefully if I keep this up every day, I'll eventually get better. All right. So radical 2 over 2, what is that? It's 1.7 divided by 2, 1.4. So radical 2 divided by 2 is 0.707. So we'll say negative 1/2, negative 1, and positive 1/2, positive 1. So we're looking at like writing here for negative radical 2 over 2, and like writing here for positive radical 2 over 2. All right. So we also have the end behavior of the graph. We know that it's going to be going through so it's going to infinity out the first quadrant and negative infinity down the second quadrant. So we have these values right here. It's not telling us that we have an intersection. What it's saying is that we have a critical point. So it's telling us that it could be, I mean, there's different critical values that it could be. So we have these 2 points. And then what you do is you can use the second derivative, which is just all the second derivative is taking the derivative of the first one. So you took the derivative of the first one and got this one. So then if I want to take the derivative of the first derivative, that's how I get the second derivative. And it's called f double prime of x. And so if I want to do f double prime of x, then I'm just going to use that rule again. 6x squared minus 3 now. And this term's going to go away because of that fact. And you're going to have 6 times 2, which is 12. And then when you subtract one of your exponents, you just get 12x. So f double prime of x is 12x. So we'll circle that, or square it, rather. Box it. Okay. And what you're doing is you're plugging in these critical values into your double prime, is what it's called, to see if you get a 0. And if you're able to get a 0, then it's going to tell you you have a maximum or minimum, because the derivative is 0. Well, if you think about a linear function and lines, and it has to do with slopes of lines. So let's go ahead and just plug in. So you have f double prime of, we'll try the first one, the positive one, radical 2 over 2. And so 12 times radical 2 over 2. And this is not going to be a 0. This is just going to be 6 radical 2, but it's positive. Positive, that means that your function is increasing, I think. It's positive. Oh, I can't remember. All right, let's try the other one. F double prime of negative radical 2 over 2. And I don't think that this is going to be a 0 either. So you've got 12 times negative radical 2 over 2. And that's just going to be negative now. So that means that the function's decreasing over that in that interval. Let's see. So that's going to be negative 6 equal to. So since it's negative there and it's positive here, that just means that the function on this interval is increasing and the function's decreasing over here where it's negative radical 2. We have a crossing at x equals 2 here. So this is an actual 0 on my graph. And then I have these other two critical values. And it's at when the function is at negative 2. All right. I'm going to erase this because I don't think that I'm going to use those. It just means that it's not crossing the x-axis. And I already have my other, my actual intercept. I have it marked already. So I don't have my table. All right. X comma y. And x was 0. And y was negative 10. So I can go ahead and see how close I can get. And 10 is here. So we have a crossing here. And we have a crossing here. What is this function doing? So it's got to be, all right, what we're going to do is we're going to check, since we have negative 1/2 on the graph, let's go ahead and check negative 1/2 and evaluate our function in a couple places. Because I only have 2 critical points. And I know that something's going on at these 2 values, but I haven't really checked it yet. So let's go ahead. I'm going to erase these derivatives because I have them. And I really want to sketch the graph. I realize that I'm only taking an hour. So we're going to go ahead and just switch this. I'm going to go ahead and we'll say just a couple points. We'll say negative 1, 0. Negative radical 2 over 2, negative 1/2, 0. Radical 2 over 2, positive 1/2, and positive 1. And we'll do 1 f of x, 2x cubed minus 3x minus 10. We'll do a couple where we're plugging in, and then we'll plug in the calculator in this calculator. Really hard to get away from the calculator these days. I'm trying, but we'll have it for now. All right, so f of negative 1. So 2 times negative 1 cubed minus 3 times negative 1 minus 10. And so we've got negative 2 plus 3 minus 10. That's giving me negative 12 plus 3. And that is giving me negative 9. So at negative 1, and then negative 9. 9 here. So here. Okay. And then that went so well. Let's go ahead and do it for positive 1. That should be easy enough. So f of positive 1 is going to be 2 times 1 cubed minus 3 times 1 minus 10. Okay. So 1 times 2 is 2, minus 3 minus 10. And looks like I'm at 10, 13, negative 11. So positive 1. What is this function doing? Negative 1. Okay, so I'm there. All right, so I'm going to go ahead and so I can kind of save a little bit of time because I realized that I was messing around. So I'm going to put this function in the calculator, 2x cubed minus 3x minus 10. And we'll go ahead and put negative radical 2 divided by 2. Negative fraction. No. Negative 8. So I did f of negative radical 2 over 2, and I'm getting negative 8. So we're here. Let's skip that over just a little bit. Negative 8.5. So here I missed up a little bit. And then let's do negative 1 half. So I'm already at, it's still there. So it's negative 8. So we'll have them all a little bit closer. Wait, negative 8.5. It's a little bit further down. So I think we're approaching that. There's no way. And then maybe that. All right. What we'll do is, well, I'll have to grab it and check it. This one may be to be continued, just for the simple fact that, well, I bite off more than I can chew sometimes. And especially when you're out of practice, you're not going to be as fast. But on the other hand, it's a pretty complicated subject matter. So I'm going to give myself a break and call this a win. And probably stop there because I'm almost at an hour. And yeah, if I don't have students, then I don't really want to talk more than 30 minutes because I realize that it's probably just not that interesting. But hopefully, I mean, it is to me, and I'm sure it is to some people out there, but I'm probably not doing the very best, not the most spectacular presenter in the world yet. Maybe I'll get there at some point. But anyway, I'm really appreciative for this opportunity and throwing myself under the bus on live television. Close. YouTube is pretty close. So while I don't have a lot of viewers, I still have I run the risk of people seeing me. So that's good for me. And anyway, we'll go ahead and end there. So thank you so much for watching. And yeah, if you want to come hang out again tomorrow, I'll be back here at 6 p.m. Central Time. And yeah, so we'll just see you next time. Bye.